Now we're going to apply our understanding of the signs to determining where our quadrants are supposed to be. So if we read the question, point P is defined by the angle theta, and it's in the fourth quadrant. And tan is that. Well, what is tan again? Let's go backwards and let's figure out what our ratio for tan is. Tan is always y over x. So tan theta is y over x. That means that if it's in the fourth quadrant, to get a negative, either your y had to be negative or your x had to be negative. So it could be, here's our first option, and here's our second option. It could have been tan theta of negative 3 over 4, or it could have been tan theta of 3 over negative 4. That's how we would make a negative quadrant, like a negative fraction, if one of the numerator or denominator was negative. But only one of these relationships gives you the fourth quadrant. So if we had, remember, it's y over x, and we use a y value of negative 3 and an x value of 4. Well, an x value of 4 is here and a y value of negative 3 is there. This is a x value of 4, a y value of negative 3. That's a possibility. And that's in the fourth quadrant. This is a y value of 3 and an x value of negative 4. This says the y value is positive and the x value is negative, right there. That would be x is negative 4, y value is positive 3. We can't use this one because it only wants an answer in the fourth quadrant. Okay, determine possible coordinates for P. We figured out. So what that means is that we've got our terminal arm in the fourth quadrant, and it hits that coordinate for negative 3. I'm going to take my check mark if I can. I'm going to move it down there and draw some lines. I'm going to draw a terminal arm. It's going to be black. Good. Terminal arm, I'm going to drop my perpendicular. It's going to be green. Green. What does this coordinate mean in terms of this triangle? It means that we came x value across 4, and then we went down negative 3. Okay, that's what we did. B, find two other primary trig functions of theta in this situation, because don't forget, theta is whatever this angle is, and it's specific to the fourth quadrant. So in order to find two other functions, we're going to need to find our hypotenuse. And to do that, you need to use your Pythagorean theory. So radius squared, and I'm going to short form this. Radius squared is x squared plus y squared, and then the last step would be to take the square root. I'm going to put it all together. So the square root of x squared plus y squared is the square root of x was 4, y was negative 3, gives us the square root of 16 plus 9, 16, 26, 25, the square root of 25, woohoo! 5. Yeah! So, we are going to have a hypotenuse, or a radius of 5, which means our other two relationships of this related acute angle would be sine opposite over hypotenuse. Sine of this angle is going to be negative 3 over 5. And cos of this angle is going to be adjacent over hypotenuse, which is 4 over 5. So that's all it's asking for. It gave us tan, then it wants you to find the other two. You need to find your Pythagorean theory. We had to use our tan information to properly label the triangle. Yes, there were two possibilities here, but only one of them falls into the fourth quadrant. And then we just stated our other two values. So let's do it here. Point P is defined by an angle theta, which is in the third quadrant, and cos is negative 12 over 13. Okay, so cos theta is, let's go back and have a really quick look. Cos theta is x over r. Cos theta is x over r. So when we're thinking about the possible coordinates for P, there's only one possibility here, because the radius is never going to be a negative value. The only way you could have a negative fraction for cos and sine is if the negative is up with the numerator. You cannot have a radius that's negative, because we just saw over here, we're squaring both values, creates positive, and then we're always going to get a positive square root for the radius value. Radius is always going to be positive. So the only possibility we have here is if it was cos of negative 12, 13. So this would be our x value, and this would be our r value. So let's go, x of negative 12 is there. R of 13, they're telling us it's in the third, is going to be down there. Draw a triangle. Terminal arm. Make it black. Whoops. Terminal arm goes there. We know that's 13 units long. Drop your perpendicular. Boom. Square root. Cos is x. This is the x, negative 12, over radius. There it is there. We have to find what the y value is. Oh, our possible coordinates. Oh, we don't know what the y value is. Like, we have to find that y value in order to even answer this question. So we are going to find the y value, which is going to be y equals, I'm fast tracking. It would be x squared plus y squared equals r squared. Isolate for y squared, so you subtract x squared from both sides, then take square root. So it would be y equals the square root of r squared minus x squared, which would be the square root of 13 squared minus negative 12 squared, is the square root of 169 minus 144. Oh, math. 169 minus 144, yeah, it is 25. Square root of a 25, that gives us 5. So our y value for this question is negative 5. Why is it negative? Because it's in the third quadrant. It told us we were going down, negative 5. Okay. Then find the other two primary trig ratios, trig functions of that. So here we want to go sine of theta, which there's our related acute angle, there's theta. Sine is opposite over hypotenuse, negative 5 over 13. This was a cos question. Tan is adjacent over, no, tan is opposite over adjacent. Negative 5 over negative 12 equals 5 over 12. So tan is going to be positive there, because a negative divided by a negative is a positive.